All right, guys, I welcome you to today's lesson on more examples that have got to do with quadratic sequences. And then from the previous video, I said a quadratic sequence is going to have this formula, which is the nth term equal to this. So today I want to take time trying to give you examples on how to find this. Okay, so this is the formula that we said the nth term should have for a quadratic sequence. And I just want to say something about this C. So for a quadratic sequence, C can be a linear sequence. This C can turn out to be a linear sequence depending on what kind of a quadratic sequence we've got. We also talked about how to find A. We said A is just half of the second difference. So today I want us to look at this example that I've put up here and see how that is going to work. So let's go ahead, because the question wants us to find the nth term of this sequence here. So we are first going to find the first difference here, which all of us should be familiar with. Now that the first difference between the first would be plus 4. That difference between those two would be again plus 6. The difference between 14 and 22 would be plus 8. So the first difference is not the same. So we need to go ahead and look at the second difference, the difference between two consecutive terms. If we do that, you would notice that the difference between 4 and 6 would be plus 2. The difference between 6 and 8 would be again plus 2, which means that this qualifies to be called a quadratic sequence. So we need to go ahead and look at the nth term. So we need, from here, we are saying that our D is equal to plus 2. So this is what we need to use to find what the A is. And I stated earlier on saying that A would just be half of D. So you know what D is equal to in this case. So D is equal to 2. So let me just get that off. Just give me, yes, D is simply equal to 2. So we're just going to go and say half times 2, which gives us A equals to 1. So our nth term here comes down to 1 times n squared plus C. And I'm going to say this again, C can be a linear equation depending on how the n squared in this case is, on what the n squared is going to give us. So we need now to find C. So finding C, this is what we need to do first. We need to write our sequence that is given, like I'm doing here. We are going to say 4, 6, no, this is 4, 8, 14, and 22. Now, once we do that, we need to come up with the sequence of n squared. So you would notice that if using n squared, which is this one here, to generate terms, when on the first position, n is going to be 1. And when we say 1 squared, we are going to get 1. On the second position, when we say 2 squared, because we are saying 2 squared, this is going to give us 4. So this formula here is going to generate a 4. And then on the third position, we're going to say 3 squared to give us 9. All right, we're going to have 9 there. And then on the fourth position, we'd say 4 squared, because we are putting the position where there is n, to give us 16. So this, our n squared, is giving us this sequence here. So the duty now is to say what is missing from this new sequence here to give us the odd one, which is the one up there. So you can notice that from 1, we need to add 3. From 4, we need to add, I think, 4. And then from 9, we need to add plus 5. From 16, we need to add plus 6. So you can see that we are not adding the same constant like it was for a linear sequence here. So to find C in this case, C would be the nth term for the new sequence of differences here, which is 3, 4, 5, and 6. This sequence here, that would be C. So now our duty is to find what this C would be. So this is now going to give us a linear sequence, and that's why I started by saying sometimes C would be a linear equation. So if you look at the difference between 3 and 4 here, this is +1. The difference between 4 and 5 is still going to be +1, and then that difference and that would be +1. So this is what C is all about. C is giving us this equation here. So we need to find the nth term for these numbers here. So if you've been following me nicely, the nth term of a linear sequence, we said it's going to be the difference, which is 1 in this case, times the position, plus some constant C1, because I'm trying to differentiate this C with the C that we are trying to find there. So if you do that nicely, 1 times n gives you n plus C1. So we need to find what our C1 is in this case. So we're going to get maybe 3 here, which is on position number 1. If we put 3 there, it means we are going to have 3 equals the position would be 1 plus C1. Doing this implies that C1 would be equal to 3 take away 1, which then implies that C1 is equal to 2. So it means that the equation for the C, for our quadratic equation, would be, so let me just take this now off, would be this guy here. Where is that guy? Would be this guy here. So let me just write it here. Would be, because we found the C1, would be n plus 2. So this is what we need to add to the n squared, which is this guy here, to find our nth term. So our nth term, we can say therefore our nth term for our quadratic sequence, all right, would be equal to n squared plus n plus 2. So this is the formula that someone was using to come up with the given sequence. So I'm going to erase this to just leave some room for some proofs of some kind if you want. So you can see right away that if we want to prove that this formula is working, let's see what it's going to give us when n is equal to 1. When n is equal to 1, this formula is going to give us 1 squared plus 1 plus 2, which then gives us 1 plus 1 plus 2, which is equal to 4. And if you look at this 4, it's the same as the given 4 there. Let's try it for the last time. When n is equal to 2, this formula should give us what? 8. So now 8 is going to be equal to 2 squared plus 2 plus 2. This gives me 4 plus 4, which is equal to 8. And it's the same as that. So in conclusion to this first example, you should know that C sometimes needs to be found as an individual sequence out of the sequence that we get from what is missing to move to actually have the actual nth term. So watch out for the second example that I'm going to do. It will be posted right away. Thank you very much, and please watch out for the second example that is coming. Thank you very much. You'd be joking, guy. Download some. Don't do this. I'm loving this. What did we just do?